In this video, I'll review converting condensed structures into Lewis structures and vice versa. At the same time, I'll introduce you to the carboxylic acid functional group along with its derivatives. I strongly recommend reviewing the common bonding patterns of carbon, oxygen, and hydrogen, which you can find here and in the description. Let's get started. In this video, we're looking at carboxylic acids and their derivatives. And so right here, we're looking at a condensed formula. Let's convert this to a Lewis structure. You notice a couple of familiar things here. We've seen these before. The CH3 groups at the end of a carbon chain. This carbon is then bonded to the methylene group. And then you'll notice this carbon is bonded to this next carbon. And you see this interesting COO, and then this oxygen at the end is covered by that hydrogen. So here's the carbon. And if you look carefully, if you study the bonding patterns, you'll recognize this carbon is bonded to this oxygen, and then something else has to happen. So we cannot leave this carbon with only two bonds. So when you see this characteristic COO, and sometimes you'll actually see this written as CO2, that means we have a carbonyl functional group. So here's that CO double bond. And then we'll have a single bond going out to that second oxygen. And this last oxygen, the common bonding pattern, of course, is two bonds and two lone pairs, will be bonded to this last hydrogen. This common bonding pattern of these atoms, when you have this COOH bonded to an R group, is called a carboxylic acid. And very common in organic chemistry. Now, something interesting happens here when this hydrogen is substituted for another R group. Let's take a look at that example. So in this example, let's convert this condensed formula into a Lewis structure. Here's that CH3 group. And this carbon is bonded to this next carbon. You recognize this characteristic COO. This is an example of having a carbon bonded to an oxygen or double bonded to an oxygen. That's the carbonyl. And then we'll continue the chain with this next oxygen. Notice, rather than this oxygen bonded to a hydrogen, this oxygen is then bonded to another carbon, and this chain actually continues. So here's the CH2 group, and then we'll close up this chain with the CH3 at the end. So right here, we have this connection of atoms, and it looks similar to the carboxylic acid. However, right here, we have this R group, we'll call this R prime, but in a carboxylic acid, this oxygen is bonded to a hydrogen. But in this case, we have another carbon chain. And this functional group is called an ester functional group. Here's another carboxylic acid derivative. Let's draw the Lewis structure for this condensed formula. Here's a CH3 group. This is bonded to the CH2. And something interesting happens here, a little bit different than what we've seen before. We've seen something like this before. When this carbon is not bonded to any hydrogens and just directly bonded to an oxygen, this CO is a classic indication for the carbonyl functional group. So double bonded to this oxygen, and then the next atom, chlorine, is then bonded to a carbon. And we'll complete the octet on the chlorine like this. This is a functional group commonly seen in organic chemistry when the carbonyl is bonded to an R group, so some carbon chain, but it's also bonded to one of the halides. In this case, a chlorine. This is commonly called an acid chloride. And the acid chlorides are most common, although there are some other halogens that can bond here. The acid chloride is the more common one that we'll see in organic chemistry. Let's close with an example where we convert a Lewis structure into a condensed formula. If you look carefully, you'll notice there are two functional groups here. This is one that I introduced in an earlier video. Here's a carbonyl group, and the sp2 carbon is bonded to another carbon atom or some carbon chain. In this case, it's just the one carbon atom, but over here, we have a different carbon chain. So these are two R groups. And when you have a carbonyl bonded to two R groups, these are called ketones. And then over here, of course, we have this carboxylic acid, the COO. This oxygen is bonded to a hydrogen, and this is bonded to an R group. So right in here, we have this carboxylic acid. So let's draw this condensed formula. Going from left to right, we have the CH3. The carbonyl, recall, is just CO. This carbon does not have any hydrogen on it, so just CO. After the oxygen, we'll write the next group that's bonded to the previous carbon, and that's CH2. And then we have the carboxylic acid. I'll go ahead and write it this way. Although this section right here, you can write this as CO2H. Here's another way to write that carboxylic acid functional group.